Welcome to our video on the incredible science of tsunamis. Today, we'll take you into the depths of the ocean and explore how these massive waves are born, what causes them to form, and how they travel across the seas with unimaginable power. By understanding the origins and impacts of tsunamis, we hope to gain insight into how humans can better prepare for these natural phenomena. Stick with us to uncover the secrets of tsunamis and learn why these waves can shape coastlines and change lives. Tsunamis are among the most powerful natural events on our planet. They begin as disturbances deep beneath the ocean's surface and, fueled by massive geological forces, create waves that move across vast distances at astonishing speeds. Although tsunamis often remain invisible until they approach the shore, they contain an immense amount of energy. For centuries, tsunamis have shaped the coastlines, influenced cultures, and, in many cases, caused loss and devastation. The story of a tsunami typically starts with an earthquake deep under the ocean floor. Earthquakes in this setting occur as tectonic plates, the giant slabs of rock that make up Earth's crust, shift. The collision of these plates is incredibly forceful, sometimes causing one plate to slip under the other. This sudden movement displaces a huge volume of water, creating a powerful wave that radiates outward from the epicenter of the quake. Other natural forces like volcanic eruptions, landslides, or even meteorite impacts can also produce tsunamis, although these events are less common than earthquakes. Once triggered, a tsunami wave is unlike a typical ocean wave. Regular waves on the surface of the sea are often influenced by the wind, which creates short, choppy patterns on the water's surface. But tsunamis are vastly different. They are known as long-wavelength waves. This means the distance from the crest of one wave to the crest of the next can stretch for hundreds of kilometers. And their energy extends from the ocean's surface down to the seabed. In deep ocean waters where the ocean floor is far from the surface, a tsunami wave might only rise a few feet and can go unnoticed by ships and boats. However, these waves travel incredibly fast, sometimes as quickly as 500 to 800 kilometers per hour, nearly as fast as a jet plane. As a tsunami approaches the shore, however, the situation changes dramatically. Near coastlines, the depth of the ocean becomes shallower, which forces the tsunami to slow down. But the energy that powers the wave doesn't disappear. It is compressed, causing the wave to grow dramatically in height. This transformation can create a towering wall of water that crashes violently onto the shore. The shape of the coastline and the depth of the seabed can greatly affect how a tsunami behaves upon reaching land. In narrow inlets or harbors, the wave height can become amplified, causing massive flooding and damage. In many parts of the world, tsunamis are closely tied to a region's geography and tectonic activity. Areas along the Pacific Ocean's Ring of Fire are particularly vulnerable to tsunamis due to the high number of tectonic plate boundaries there. Japan, Indonesia, Chile, and Alaska are just a few of the places where tsunamis have left lasting marks on communities and landscapes. In these areas, people have had to learn to coexist with the possibility of tsunamis, developing warning systems, evacuation plans, and seawalls to help protect against the worst impacts. Historically, tsunamis have shaped human culture, myths, and even religious beliefs. In some cultures, tsunamis were once thought to be the work of gods or supernatural forces. Stories passed down through generations tell of massive waves that swept away villages and altered the course of rivers. These tales served as warnings and reminders of nature's immense power. In Japan, for example, folklore about great waves has existed for centuries. Many of these stories highlight the importance of living in harmony with nature and respecting its potential for both beauty and destruction. Scientists today use advanced technology to monitor the likelihood of tsunamis. The development of underwater sensors, buoys, and satellite data helps detect seismic activity that could lead to a tsunami. Seismic activity on the ocean floor triggers alarms in these systems, sending data to tsunami warning centers. If a tsunami is likely, these centers issue alerts to coastal regions, giving people time to evacuate to higher ground. While technology has made it possible to detect tsunamis more accurately, predicting exactly when and where a tsunami will hit is still a challenge. Once a tsunami warning is issued, communities go into action. In coastal towns with effective systems, residents are often trained to recognize natural warning signs of tsunamis. These include sudden, unusual changes in sea level, such as the ocean receding quickly from the shore, exposing areas of the seafloor that are normally submerged. When people see the water pull back from the shore in this way, it is often a prelude to a tsunami wave. This visual warning can give precious minutes to escape, which can make the difference between life and death. The destructive power of a tsunami does not end with the first wave. Tsunamis often consist of multiple waves, each spaced minutes or even hours apart. Sometimes the first wave is not the largest, and the second or third waves can bring even more devastation. After these waves hit, communities are often left in a chaotic state, with damaged infrastructure, homes, and environmental impacts. Floodwaters may remain for days, contaminating drinking water, disrupting power, and increasing the risk of disease. The aftermath of a tsunami can be overwhelming for communities. In addition to the physical destruction, tsunamis can have lasting economic impacts. Roads, bridges, schools, and hospitals are often damaged, making it difficult to rebuild and recover. For people who rely on fishing or tourism, a tsunami can mean months or even years of lost income. The environmental effects are also significant. Saltwater can inundate farmland, making it difficult for plants to grow. Marine ecosystems are disrupted as habitats are destroyed or altered. While tsunamis are natural events, human activities may sometimes play a role in increasing vulnerability. Coastal development, deforestation, and climate change can all contribute to the risks associated with tsunamis. Removing natural barriers like mangroves or coral reefs can leave coastal areas more exposed to wave energy. Climate change may also influence the frequency and intensity of certain extreme weather events, which could indirectly affect tsunamis. Preparedness is one of the best defenses against tsunamis. In places with a high risk of tsunamis, building codes, zoning laws, and coastal barriers can reduce the impact of these waves. Communities that practice evacuation drills and education programs help residents understand what to do in the event of a tsunami. With the right combination of technology, community planning, and individual preparedness, the impact of tsunamis can be minimized, although it is impossible to eliminate the risk entirely. While tsunamis are awe-inspiring in their power and impact, understanding them can help us coexist more safely with these forces of nature. By studying how and why tsunamis occur, scientists and communities alike gain valuable insights into how we can protect ourselves and minimize the harm that these natural phenomena can cause. Through awareness, preparedness, and respect for nature, we can reduce the devastating effects of tsunamis and appreciate the interconnectedness of Earth's dynamic systems.